Hello. All right, so 3D is going to focus on linear inequalities. So we're still going to be doing a lot of graphing, but there's going to be a coloring aspect to this. So hopefully that's some good news. All right, so just kind of a review of inequalities. So this is throw back to unit 1. So if I have x greater than -2, so what I mean by this is going to be an open circle, and it's going to shade to the right. So we're going to be bringing kind of these aspects back. So I want to open circle at -2. So 2 above and 2 below. And I want to shade to the right. So up and right. All right, then over here, so this would be a closed circle. And this would be going to the left. So I have a closed circle at 4. Wow, I am terrible at coloring. There we go. So this is at 4, 2 above, 2 below, and it's going to go to the left. All right, so we're actually going to be doing the same ideas, but now on a graph. All right, so we want to write 5x minus 4y equals 20 in slope-intercept form and then graph it. So first we have to convert. So what I mean by that is we're going to be solving for y. So I'm going to subtract 5x first. So I'm going to have -4y equals -5x plus 20. So I want it to resemble slope-intercept form, so I'm going to keep the x value on the first value. So now I'm going to divide by -4. So I'm going to have y equals -5 over -4x plus 20 over -4. So now I just want to kind of clean it up and simplify. So two negatives make a positive. So I have 5/4 x. Then positive 20 divided by -4 give you -5. So in this case, our slope here, we have a slope of 5/4 and a b value of -5. So that means we're going to start at 0, -5. So at 0, -5, I'm going to start down here and go up 5, right 4. So I'm going to be at this point. So 1, 2, 3, 4, 5. 1, oh wow. 1, 2, 3, 4. So we can't actually plot any other lines. So what I'm going to do is just draw a line that connects both and extend. So this is really an extension of what we did in 3B when we're graphing. So we're going to be doing this in addition to some shading. All right, so with inequalities, we actually want to determine a solution. So in this case, I want to be given a coordinate and I want to be given some sort of inequality, and I want to determine if that point is going to be a solution. So for it to be a solution, you have to produce a true statement. If it's not a solution, it will produce a false statement. All right, so what I want to do is I want to take this x and y, and I'm going to plug it in their respective area. So I'm going to have 4 less than 2 times -2 plus 1. So I want to see what's going to happen. So I'm going to have 4 less than -4 plus 1. So I have 4 less than -3. Well, that's not true. So this is false, which means this would be not a solution. All right, so for the second one, same idea here. So I'm given some x, y. So I have 1 greater than 3 minus 4. So 1 greater than -1. Well, that's true. So that means this is a solution. So you literally just write solution and check. All right, number 3. So once again, I have my x, y. I'm going to plug them in. So 5 less than, nope, 4 plus 1. So you want to see, is 5 less than 5? So the issue here is this is actually false, which means this is not a solution. So what I mean here, however, if it was written like 5 less than or equal to 5, that would be true because I can also be equal to it. But here, because I cannot be equal to it, that's what makes it false. All right, so over here, so I have my x comma y. So I have 1 greater than 1 minus 7. So 1 minus 7 gives you -6, and 1 is bigger than -6, which means this is going to be true. That is terrible. Which means this is a solution. Okay. So now we're actually going to move on to the graphing aspects of this. So whenever we're graphing, we're still going to be doing the same thing that we did in 3B, but we're going to be extending it by a little bit. So what I mean by that is we want to look to see what kind of inequalities we have. So if I can be equal to it, then I want to draw a solid line. However, if I cannot be equal to it, meaning if this is our inequality sign, just strictly less than or strictly greater than, that means we have to use a dashed line. So luckily Notability now has a dashed line option. All right, so, and then if we are greater than, then we want to shade above, whereas if we are less than, then we want to shade below. So just to kind of give you a quick little reference, a quick little chart. So I call this my little quick reference chart. So you can use this if you want, you don't have to, but it's just kind of a, like I said, a quick reference. All right, so if I have greater than or equal to, greater than, less than or equal to, and less than. So on the left side over here, this would be we shade above. And then down here, this would be if we shade below. Oh, my handwriting is so terrible. All right, and then up here on the top, this is if it's a solid line, and this will be if it is a dashed line. So if I have greater than or equal to as my inequality sign, then I know it's going to be a solid line and it's going to be shaded above. So if I have a less than inequality sign, it's going to be a dashed line and it's going to be shaded below. So if I have greater than, dashed line, shade above. If it's less than or equal to, solid, shade below. So just kind of a insight on how to use that. All right, so you have to ensure that your equations are going to be in slope-intercept form. So here's the thing. I've gotten this question every time. Can I use the standard form trick on questions like number 2? Well, the answer is no. Unfortunately, no. And it's because of the shading aspect. If we were just graphing, then yes, you could. But because of the inequality sign, we have to be able to convert. So I'm going to be converting on every single one of these. So in this case, when I say convert, we want them to be in slope-intercept form. So in this case, this one's already in slope-intercept form, so we don't have to change anything. So I'm looking at my inequality sign. So because I have less than or equal to, what this means is this is going to be a solid line. And because it's less than, I want to shade below. So I'm still going to do like the open or closed slash left or right. But instead of open or closed, now it's going to be solid or dashed. And instead of left or right, now it's going to be above or below. So now you want to graph. So I have a slope of 2 and a b value of -3. So I'm going to start at -3 and then apply my slope. So up 2, right 1, up 2, right 1, up 2, right 1. So hopefully this lesson's a little bit more exciting since you guys get to color. Kind of. All right, so now what I mean by shading, now you actually want to shade a side of that equation. So to determine if it's above or below, you can also use this quick reference chart that I have made. So you want to look to see what kind of slope you have. So if you have a positive slope, this will help you determine above and below. If you have a negative slope, above and below. If you have zero slope, above and below. Hopefully this one should be pretty straightforward. I've tragically had people get that part wrong, which was a major facepalm moment, but you know what? I'd probably do the same thing. So an undefined slope, above and below. So this really tells you which side is above, which side is below for shading. So because I have a positive slope and I want to shade below, I want this side of the equation. So I want to shade this side. So when I mean shading, you can literally just do a squiggly line like that. You could even use the highlighter to do the squiggly line, or you could do a different color squiggly line, or you could literally be the meticulous person that literally colors it in. I don't care how you do it. As long as you make it obvious which side is shaded, then you're good. All right, number 2. All right, so you have to convert. Unfortunately, no way around it. So subtract 5x, subtract 5x. So 2y greater than negative 5x minus 8. So now I'm going to divide by 2. So y greater than, so I have negative 5 over 2x minus 8 over 2. So now I'm going to do any simplifying. So 5 over 2 cannot simplify, so I just leave it as negative 5 over 2, then minus 4. All right, so in this case, now if you look at your inequality sign, so what this tells us is this is going to be a dashed line because we cannot be equal to it, and because it's greater than, we want to shade above. All right, so now I want to look at my slope and my y-intercept. So I have a slope of negative 5 halves and a b value of negative 4. So you're going to start at negative 4, and then you want to apply the slope of negative 5 over 2. But if you look here, 1, 2, 3, you can't do negative 5 over 2. So what that tells you is you have to go the other way. So instead of going down 5, I'm going to go up 5. 3, 4, 5, then left 2. So 1, 2. So I'm going to put a point here. All right, so I'm going to go again. So 1, 2, 3, 4, 5, 1, 2. All right, so I want a dashed line. So just to show you guys how to access the dashed line, just in case you don't know. So you want to click on your pencil. And now over here, you want to actually swipe right, nope, swipe left. And this is actually a menu now. So over here, the first one on the left on the second menu is actually a dashed line. So then you can press and hold, and it's the same mechanics and idea as the other one. So you can press and hold, extend, so far, etc. So when you're doing your arrows, just make sure you go back to a solid line. Also, just general best practice, I would say take off your pressure sensitivity. So I would just say make sure you're using this very first when you're writing. It's cleaner. All right, so now we got to do the shading. So we have a negative slope. So that means I want the top side, the top right. So that means I want everything over here. All right, now for number 3. Okay, so you want to solve for y. Now here's the thing. Typically I would say move everything to the right side, but there's a convenience with this one where you can do it in one step. So if you look here, see how we have a negative y? If I add y to both sides, then you'd have 3x plus 2 less than or equal to y. Y is by itself, but now you just got to switch it over. So remember the LOL rule. So letter on the left. So I'm going to put y on this side. So y greater than or equal to 3x plus 2. So in this case, we have a solid line, and it's going to be shaded above. because it's greater than. All right, so our M value here is 3, the B value of 2. So I'm going to start at 2 and then go up 3, right 1. So start at 2, go up 3, right 1. So I'm going to go down 3, left 1. All right. So now we have a solid line. There we go. Now I want to shade above, so we have a positive slope. So I want the top left. So I want this side. All right. Number 4. All right, so we're bringing back Hoy buffs. So in this case, because it's a Y, we're going to be using Hoy. So this is a horizontal line at +2. And notice how it's dashed. So we're going to have a dashed line. And then we want above because it's greater than. So I'm going to switch over here to a dashed line. Go at +2. Nope. Go back to solid line. All right, so we want everything above that line. So we want everything on the top here. So that would be our shading. All right, that's all we have on that one. So now number 5, same idea, but now instead of Hoy, now we have an X equals, which means we're going to be using bucks. So this is a vertical line. So here, looking at our inequality sign, we want a solid line. And it's going to be shaded above because it is greater than or equal to. So I'm going to go to -3, draw a vertical line on the x-axis, or according to the x-axis. And I want everything above, so I want everything to the right. So everything over here is what I want. Okay, now number 6, this is the gross one. All right, so first thing I'm going to do is I want to solve for y. I'm going to get y by itself. So if you notice, you actually have a -y. So your option here is you can actually just add it over so that you don't have to do any flipping or whatever. But what I'm going to do first is distribute. All right, so we have a -4/3 times 6. So that's going to give you 8. Yep, so -8x. Then -4/3 times -3, which is going to give you a +4, less than or equal to -y minus 2. So I'm going to go ahead and just add over this y. So I can go ahead and just put it on the left side. All right, so I'm going to have y minus 8x plus 4 less than or equal to -2. All right, so now I'm going to add over the 8x. So I have y plus 4 less than or equal to 8x minus 2. Now I need to get rid of that 4, so I'm going to subtract 4. So I'm going to have y less than or equal to 8x minus 6. So if you look at your line here, it's going to be a solid line. And because it's less than, we want to go below. So we're going to start at -6, and then we're going to go up 8, right 1. So 1, 2, 3, 4, 5. So start at -6, and then go up 8, right 1. So we can only put 2 points. Solid line. Oh my gosh. I'm going to extend. And there's that. All right, so now we got to do the shading. So we want below, so this is a positive slope, so we want the bottom right section. So we want this side. Okay, so definitely make sure you're going to take advantage of the quick reference chart down here. And I would definitely say make sure you take advantage of the quick reference chart up here. They are both extremely helpful in this lesson.